Hello everyone and welcome to a surge protection lockdown lesson with me, Earl from Dane UK. For this session we shall be looking at the Type 2 SPD in a domestic installation, and specifically we're looking at the fusing. Now there are some requirements of 7601 need to be aware of. We need to be aware that the minimum cable size is 6mm square and that the distance of that cable is no more than 500mm. That comes from 534.4.10 and 534.4.8. Now the parameters of the Type 2 SPD are mentioned in 534.4.4.4.1, nice catchy reg there. And the discharge current minimum of IN is 5000 amps. And this is where we start to work out whether we need overcurrent protection or not. Now we need to ensure that whatever the manufacturer's instructions say, it raises the bar above the minimum requirements of 7671. We're going to compare two types of Type 2 SPD. One is going to be 2 modules wide, one is going to be 1 module wide, and we need to also be aware of the characteristics of the service head fuse. So it's either going to be a BS1361, which is going to be rated at, say, 33 kA, or a BS88-3, which is going to be 16 kA rating. Need to remember those values for later. So what we're going to do now is compare these two SPDs. Now I know from the datasheet that this 2 module one has a fuse rating of 125 amps. I can also see from the side of it that it's got an IN of 20 kA, and I know that its short circuit rupture capacity from the datasheet is 50 kA. This smaller single module unit, that's got a fuse rating of 63 amps and it's got a surge current value of 5000 amps. In terms of protecting the smaller unit, I could do that with a simple ordinary MCB, which has got a value there of 6000 amps rupture. So with the rupture capacity of 6 kA here and in here, I will have a fully coordinated 6 kA surge protection device assembly or circuit, and that's the sort of thing that we're looking for. Now one of these two SPDs I'm going to fit into the dwelling, which has got a 100 amp service fuse, and we're going to look at the documents in the 61643 series, which is all about surge protection, to work out what the maximum fuse rating is likely to be. So we're going to have a test bed, we're going to have to rig up some fault currents to see when the SPD stops failing safely, and that's when we work out when air fusing is going to be required, because each SPD has the capacity to interrupt a circuit without damage, and there's going to be a tipping point when additional fusing is going to be required. Right, now when I was talking about an SPD test bed earlier, this is really what I had in mind. Sorry about that. Now what we're going to do is we've got on the left here a surge impulse generator, and that's going to zap both of these SPDs with increasingly high values of surge current, and that the SPD is going to have to be able to disconnect at these increasingly higher values that are going to be passed through it. Now the way that the IEC standard does this is to see how the SPD gets stressed and gets hot with these increasing currents. And the way that they do that is to put a piece of muslin cloth over each device. Now we haven't got any cloth, so I'm going to use loo roll because we're in lockdown mode and this is just as valuable. So as we ramp up the test values, there come a point when one SPD is going to start to get hot, and that's going to be manifest by it sort of discolouring the actual thing itself before it actually bursts into flames. And that is the point where we then know, well, that's the limits of that device. In this case 63 amps, and we use a corresponding overcurrent protection device, and this one is rated 125 amps because it can deal with correspondingly much higher values of surge interrupt or short circuit withstand. So that's 6000 amps and 50 kA respectively. So that gives you a feel now for the differences between the two devices. So now we know what the fuse ratings are and how we came about them. And we know about the failure mode of an SPD. And that is why for any domestic installation with a service head below 125 amps, the 2 module SPD isn't going to need any overcurrent protection added to it whatsoever, because it can isolate all faults safely. Its ISCCR is 50 kA, well beyond the two commonly used British standards fuses which we expect to see in a service head. The single module SPD, however, is more than likely going to need an additional overcurrent protection device because its raking capacity is only 6,000 amps, so it won't be able to deal with any value above that without additional protection. It's always going to be useful to look at this short circuit rupture capacity to get a measure of the performance of an SPD, and therefore you can make some more informed product selection. And you know that whatever the fault current will be at this location, that the SPD will be working afterwards. So in conclusion, for me, it's going to be the 2-module SPD that I would install in the installation because it requires no additional parts, no additional linking cables, and I know that whatever the fault capacity is at the installation, that my SPD is going to be fine and working again afterwards. So that's it. That's surge protection in the domestic dwelling, and thanks for watching. I'll see you again soon.